In your first round of CPW science as juniors, we're going to first perform a simple interpolation using data in a table or graph, then perform a simple extrapolation using data in a table or graph. We're going to understand a simple experimental design, and then we'll compare or combine data from 2 or more simple data presentations. We know we'll be successful today when we can predict a correct answer using a data table in the first 2 questions, determining the purpose of an experiment based on the experimental variables, and then determining the best combination of experimental variables to achieve a desired result. In our first question, it asked in experiment 1, the time constant of the circuit was the time required for the voltage across the capacitor to reach approximately 7.6 volts. So the time constant of the circuit used in experiment 1 was what? So if we're looking at experiment 1, that refers down to table 1. But in my table, there's no 7.6 volts. I go right from 0 to 8.4. So that means I have to look within the data table and perform an interpolation based on the information that I have. So because 7.6 is in between 0 and 8.4, I can assume that the time would be 12 seconds or less. So the answer to number 1 is A. In our second question, it asks if in experiment 2, a 1.5 times 10 to the negative 6 farad capacitor had been used, the time required for the voltage across the capacitor to reach 6 volts would have been closest to what? But after looking at my data table for experiment 2, which is table 2, I have capacitances of 0.1, 0.3, 0.6, and 1.2. So 1.5 would be up here. So we're predicting a result of a trial that wasn't taken. So there's a couple options here. Option 1 is that you can look at the numbers and they're going up slightly. There's no really big jumps. You can determine an answer from that. So you can kind of look at the order of numbers. Or option 2 is that you might have been able to tell that there's a ratio. So we have 0.1 to 0.7, so 0.1 capacitance to 0.7 volts. And that's actually the same as 0.3 capacitance to 2.1. So what we can do is we can set up a proportion. So we can say if 0.1 times 10 to the negative 6 capacitance yields 0.7 seconds for the time to reach 6 volts across the capacitor, I can predict what would happen with 1.5 times 10 negative 6 farads over x. And x is equal to 10.5 seconds. So your answer for number 2 is C. And number 3, it's asking what the main purpose of experiment 3 was. And in order to figure this out, we're going to have to look at the experimental variables, our independent, dependent, and the controls or constants. Remember, our independent variable is what we're testing. Our dependent variable is what we're measuring. And control or constant variables are things that are being kept the same to determine that the experiment is valid. So the experimental variables, usually the easiest one to find is the dependent one because that's what we're measuring, and that's usually pretty explicit. That's actually in experiment 2, it's the time, because they use the same procedure. So they're measuring the same result. But in this experiment, in contrast to experiment 2, they are using different resistors. So that's what they're testing. So the type of resistor is what they're testing. And then things that they're keeping the same are the capacitance value, so the type of capacitor, and if they're using the same procedure as before, they're also using a 6-volt battery. So in this experiment, they're looking on the effect of the resistor to time. So after analyzing experimental variables, D is my best answer. because both B and C are saying that the capacitor is making a difference, and it's not. It's one of the things we're keeping the same. And the battery's voltage is also something that we're keeping the same. So D is our only viable option. In the last question, it wants you to consider the circuit shown in figure 1, but you actually don't need that image. All you need to do is to compare the data tables for experiment 2, which is table 2, and experiment 3, which is table 3. So if we want to determine the combination of variables, the capacitance and resistance, to have the shortest amount of time, we have to pick out the values that give us the shortest amount of time based on the data table. So in blue here, I've kind of identified the capacitance, which is 0.1 times 10 to the negative 6th. So both the value are in both A and B. But in table 3, 0.25 times 10 to the 7th is the resistance needed to have the smallest amount of time, and that's in answers A, because 0.25 rounds up to 0.3, and C. So the only answer that has both of those options in it is A. So to recap, the answers for CPW Science for round 1 are 1A, 2C, 3D, and 4A. Until next round, guys.